Boom! Okay, think of me like one of those baseball crazies entering statistics in a journal. Except that I'm a fan of physics! Oh God, did I say that? I strongly suspect this superstring theory has opened the door to a revised understanding of the cosmos that might eventually be seen as comparable with the realization that the Earth is not the center of the universe. String theory has been called the theory of everything. Albert Einstein was attempting to finish his ambitious last opus, the unified field theory, when he died. The goal of the unified field theory was to bring together the forces that were understood at that point that account for the universe around us under the umbrella of a single grand unifying model. Einstein mentioned often during this period that he needed more mathematics. String theory attempts to accomplish the same goal via the introduction of higher dimensions. More mathematics indeed. The four forces that all this hubbub is about are the strong, the weak, the electromagnetic, and gravity. Gravity does not work and play well with others. Now it seems the big problem is that gravity doesn't fit with the other three forces. And for another things, it's billions of times weaker than the other three forces. Give me your lunch money! So any theory that attempts to unify all four forces must account for this discrepancy. In addition, the theory that works so beautifully to explain gravity, the general theory of relativity, which was a solo effort by the great Albert Einstein, inhabits another universe from the theory that works quite well to explain the strong, the weak, and the electromagnetic. So while general relativity is positively symphonic in its elegance and beauty, quantum mechanics has been compared with the splashy, drippy, chaotic paintings of Jackson Pollock, whose work I happen to like. The famous Danish physicist, Niels Bohr, who is a giant in the history of 20th century physics, is to quantum mechanics perhaps in a way what Albert Einstein is to gravity. They were friends, Albert Einstein and Niels Bohr, and Albert Einstein is famous for saying, "God does not play dice with the universe." To which Niels Bohr replied, "Albert, stop telling God what to do!" What string theory does is to resolve this seemingly monstrous disconnect between these two very different theories via the introduction of higher dimensions. 7 extra dimensions, in fact, which brings us to a grand total of 11 dimensions. So that wacky through-the-looking-glass quality that seems to pervade the world of the subatomic, where quantum mechanics rule, can be explained by the brilliant notion, I really like this notion, that we're forced to view it from our very limited 4-dimensional space-time continuum perch. It's like an iceberg, and you can only see the tip. Better yet, the allegory of Flatland will help illustrate the situation. Imagine you're a 2-dimensional being living in a completely flat Euclidean 2-dimensional world called Flatland. Imagine now that a sphere comes for a visit. Now let's suppose that this sphere really likes what it sees and decides to pass through Flatland to take a better look. What you would observe as a flatlander would be at the very least inexplicable and impossible based on the worldview that you will have invariably formed from experience. First you would see a single point appear out of nowhere. Then you would see this point magically expand into a circle. Then the circle would continue to expand until the sphere reached its full circumference or equator. Then the circle would begin to shrink until it became a point again, before disappearing. To a flatlander, the phenomenon just described would be completely incomprehensible, not to mention impossible. That's because a flatlander could never wrap his brain around a ball or a sphere. We are the flatlanders. Let me try to explain. Let's apply a similar strategy in an attempt to gain a little insight into a 4th spatial dimension, because we have 4 dimensions that we use, but time is one of them. So let's try to introduce 5 dimensions. Wasn't that a group? A similar strategy would be, first we have to imagine a 4-dimensional cube. This is called a tesseract. It has a name, or a hypercube. Now I mentioned typing hypercube or tesseract into YouTube. It's a really good idea because there's some great illustrations, moving cartoons, yes. So let's introduce hypercube or tesseract. Now we can't actually visualize or even imagine a 4-dimensional cube, but we can mathematically define it. Well, I can't, but some people can. The projection in our 3 space, think shadow, would appear solid, like an object, think hologram. But as you rotated the tesseract hovering above in 4 space, above our 3 space, which we can't imagine doing that, some crazy things would begin to happen. You might see a box, inside a box, with the vertices connected, you know, the corners. But the box inside would begin to grow simultaneously, while the box outside would begin to shrink, and then they would move outside of each other, and all the vertices would remain connected, and then the inside box would take the place of the outside box, passing impossibly through the outside box until they trade places with each other. That's one kind of rotation. Then the whole thing would start again. It's like breathing. Now we must remind ourselves that we have just been observing only a shadow, not a tesseract. This is not a four-dimensional cube that we're observing. We're observing a three-dimensional shadow, or a three-dimensional projection of a four-dimensional cube into our space. The object that we can't imagine existing in 4 dimensions is this tesseract. We are the flatlanders who can't wrap our heads around a ball. Now, if we can't imagine 4 dimensions, how about 11? Oh yeah, and I forgot to mention, superstring theory demands a multiverse. Superstring theory is one of 3 very well-known theories. The theory of inflation and the theory of dark energy, even quantum mechanics itself, kind of hints at a multiverse. There's lots of arrows pointing at multiverse. It's not like these physicists are out there saying, oh, we're gonna grab any theory that says multiverse. They're not. They weren't. They haven't been. It's just kind of what the numbers are telling us. So, if there is an 11-dimensional multiverse, let me be the first to say, I feel like an ant! Like an ant! I feel like an amoeba! It's ridiculous. And that's a good thing if you do feel that way like me, because it should be a bit overwhelming. But at the same time, it's kind of exciting, isn't it? Huh? I mean, isn't it? Come on!